fractions. So now on to a new chapter and a new topic. So this chapter is called, or at least this part is called Numerical Methods. So if you can just write this down. Yeah. Yeah? Okay. So before we do anything new, let's do something a little bit old. Can you just write down this cubic? The first one there. Can you see it? Did you write it down? Can you write it down?
Yeah.
Got it? Right, so, what's the cubic?
Minus 10x cubed plus 3x squared plus 37x minus 18.
Minus
18.
How can we know how many roots this has without having to find the roots? That's only for quadratic. You can know by finding the turning points. Watch. Minus 30x squared plus 6x plus 37 equals 0. Yeah? Let's see, how did I get that minus 30? What did I do? How did I get this? Yeah, what did I do? Come on, wake up. How did I get this?
You put the 1.
Ah! Derivative. Yeah?
Yeah.
And if I want the turning points, I make the derivative equal 0. Yeah, okay. So let's solve this. Minus 30, 6, 37. So you have two solutions here. You know, I actually didn't have to solve it. I could have just used the discriminant here and I've discovered that the discriminant is positive, so that means it has two solutions. Yeah? So it has, well, let me get them back here. 1.2 and minus 1. So here at 1.2 and here at minus 1, there are turning points. Yeah? We can take these two numbers and put them both back into this cubic. So we can just do this roughly in our head. This is about equal to 1, isn't it? So if I put 1 in here, do I get a positive or negative? Minus 10 plus 3 is minus 7, plus 37 is 30, minus 18, so positive. So it'll be somewhere up here for sure. And then if I put in minus 1, I get 10 minus 3 is minus 13, minus 37. So I get definitely a negative. So there's a turning point up here and one down here. And you remember this cubic? It usually goes up, down, up. But when it's a minus, down, up, down. Is that right? Yeah. So down, up, down. And this point here is, oh no, I drew that a bit bad. Down, up, down. And this point here is minus 18.
Why didn't you take it from down?
Huh?
Why didn't you take this from down? Why you discuss? First it was from the upper side, but then you took it from down.
Here?
Yeah.
Because I knew it should go to minus 18 when x is 0.
If I knew that.
It doesn't matter. I'm just trying to make it nicer. How many roots does this have? 3. So it has 3 roots. If both turning points were above, how many roots would it have?
2.
No. Down, up. Oh, I drew that bad. Let's say there was 1 and minus 1. Oh, I drew that bad too. There. Down, up, down. So it only has 1 root. What if there was 1 turning point above and then 1 on the axis? How many would it have? Yeah. Down, up, down. It would have 2. What about if both turning points were below? Like this.
1.
Yeah. Down, up, down. So, by drawing a quick graph...
No one?
Huh?
No one? The last one.
What?
How many roots?
1. Yeah. So by drawing a quick graph, we can know how many roots there are. So this is your first example. Do you want to write that down? He does.
So positive it goes down, no, up, down and up.
Up, down, up. You got this? Okay. Let's have a look at the next one. Yes, Mir?
Yes.
Okay, the next one. I want to show that there is a root between 0 and 3, for example. So if you can write this one, show that this cubic has a root between 0 and 3. Got that? Okay. What was my cubic?
8x cube.
What?
8x cube.
Yeah.
Minus 30x square. Plus 54x minus 25.
And I want to show that there's a root somewhere between 0 and 3. So I want to prove it crosses the axis between 0 and 3. Any ideas on how I could prove that?
You just do the same stuff that you do.
Could, but there's a little bit of an easier way. Any ideas? What I'll do is I'll take 0 and put it in here to get the y. And what do I get for y when x is 0?
0, 0, 0, minus 25.
So we know that it's here. Now let's take the 3 and put it in. So we'll have to do this one here. Can you write as I'm writing? It might be a bit quicker. 8 3 cubed minus 30 times 3 squared plus 54 times 3 minus 27, and I get 81. So then here it's at 81. So when I draw the curve, I know it must cross somewhere in between 0 and 3. If one value of y is negative and one value of y is positive, then it must have crossed the axis in between. So you could say, since since y when x equals 0 is negative and y when x equals 3 is positive, that must mean there's a root somewhere between 0 and 3.
What was the answer of y when we put 3?
81. Yeah. You got that? Okay. Let's go on to something new now. Going to scroll down over here. Okay. Something new, or maybe not new for you. Do we know how to solve linears? Of course. Quadratics? Cubics? Kinda, yeah. What about something else like power 4? No. We can't really solve every type of problem. Like if I gave you an equation like this, we have no way to solve this. It's too difficult for us. Or what about if I gave you an equation like this? Can we solve this one? No. So we need some way to solve any equation. And this is where our friend Newton comes back. There's a method called Newton-Raphson. Let me explain the idea. We have some graph. I'll just draw it like this. I'll make it like a quadratic, for example. And we don't know what the answer is. Remember when we were doing cubics, or when you were doing cubics, first you have to guess a root. Remember this? So you start off with 0, then you try 1, then you try 2, then you try 3. But this can take a long time. Maybe there's a better way to do it. So, the idea goes like this. Let me just call this y equals fx. First, you make a guess at the answer. So maybe you guess x0 is the root. Is that the right answer? No, because the root is here.
Yeah.
So we were wrong. But what we do, we go up to the curve, and then here we make a tangent. It's a tangent, trust me. And then where the tangent crosses the axis, we'll call that x1. Which is which is closer to the answer? x1. So let's pretend we try x0 and we want to find x1. So let's find this tangent line. So what's the equation of a tangent, or of a line?
Y minus.
You could go with that, y minus y1, yeah, or I prefer y equals, yeah. How do we get the m for a tangent? Do you remember that in semester 1? Yeah. So y equals the derivative at x0, x plus c. And how can I find c? I use a point. I only have one point. Here it is here. It's x0, f x0. You see that?
Yeah.
So let's put that point in. We get f x0 equals f derivative x0, x0 plus c. So c equals f x0 minus... Yes? Is it okay? Or not okay?
Yeah.
It's okay? Are you sure?
Yeah.
f x0 minus f derivative x0, x0. We can put that back in, and we get y equals f derivative x0, x plus f x0 minus f derivative x0, x0. Now, how can I find x1? How can I find that? I know the tangent line, so how can I find x1? Come on, you're looking at me like you're sleepy. How do I find x1?
I was stuck in this.
Please tell me.
How do you find x1?
Yeah, if I know the tangent line, how can I find x1?
By the slope.
No, come on, wake up, wake up. How do I find it?
Left point.
Guys, come on, wakey, 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 wakey. How do I find this point if I know the line?
A point.
No? Make y 0. Right? How do you find the root? How do you find where it crosses the x-axis?
Value.
Yeah, so make y 0. You're looking at me like, I don't know, what's wrong? Okay. So, how do I find x1?
By equals to 0.
Yes. So now I have 0 equals f x0 x plus f x0 minus f derivative x0 x0. So I get x equals f derivative x0 x0 minus f x0 all over f derivative x0 when I rearrange this. What can I can divide. So my answer, x, or I should rather call it x1, is equal to x0 minus f x0 over f derivative x0. So what we've just done is we've found a way to improve our guess, a better answer than our answer. I will pause for a minute to let you write this down because I need to continue with this. Okay, so I'll pause, you write this much down. Yes. What's wrong? You don't look happy.
Is it Newton-Raphson proof or what?
I'm nearly finished the proof of a formula.
Why is the y equal f(x0)?
Why is the y equal f(x0)? Why not? Because this is x0, and if you want to know what the y is, you have to put put this in here to get the y. Yeah? Now, have a look at this. Let me draw something for you. Let's draw a simple cubic. Y equals x minus 1, x plus 3. Graph it. Graph it. X minus 1 times x plus 3. Simplify, expand. Right, there is my quadratic. What are the roots? 1 and minus 3. Let's pretend we guess a root, and let's pick the wrong answer. Let's say I guess that the root is 3, or 2 even. Let me zoom out a little bit. Okay, is the root 2? No. Is it 3? No. Let's guess 3. So let's just say f of x is this, and let's put in 3. Will I get 0? No. Let's see what I get. I get 12. 3 gives me 12. 3 gives me 12. So I was way off. Wasn't even close to 0. But let's use this new formula I have that says a better answer is my old answer. If you want to think about this, better answer equals old answer minus fx0 over f derivative x0. Do we have the derivative? No, let's calculate it. What's the derivative here?
2x plus 2.
2x plus 2, isn't it? Okay. So, what happens when I put in 3? Let's see what I get. I get 8. So the rule is, the better answer equals the old answer, which is 3, minus, and then what's on top? Fx, f3, what's f3? 12, divided by f derivative, which is 8. So this should be closer to the true answer, which is 1. Let's see what we get. 1.5.
Wow.
Yes. Now, I can show you here. No, that's not it. How do I draw a tangent line? No. I can't remember how to do a tangent line. Let me just check. No. I like drawing pictures. Search. Oh, no search. Doesn't matter. I can't remember how to draw the tangent line. Tangent. Maybe this is it. Aha, yeah. Great. So what happened was we tried 3, and of course 3 was the wrong answer. Then our formula drew a tangent line and then gave us this number, which would be a better answer. But then you might think, well, why don't I just repeat this? Why don't I now use this point, go up, draw another tangent and get even closer? So we do it again, except with 1.5. See the green line? Let me zoom in. So what we did was we took 1.5, we put it into the formula again, it went up, it drew a tangent line, and look how close that is now.
So when will we know that the answer is 1? Like,
it doesn't actually get to 1, but it gets closer and closer each time.
Is it possible that I pass 1?
And we'll talk about that passing it as well, yeah. So you might think, oh, so I could just keep using this formula until I keep getting closer and closer to the answer. and we can have this sequence. This is called Newton-Raphson's formula, and it's a way to get to the answer by repeating a process to move to it. Do you understand what I mean? So this I will do with a simple example now. Okay? Smart man. Okay, continue. Let's pick an example where we know the answer, okay? So, suppose I want to solve this equation. What are its roots? What are its solutions? Plus or minus 2. Yeah? Let's pretend I didn't know that and I just totally guessed the answer and I say, I'm going to try 10. Am I right? No, I'm way off, way off. But this formula tells me how to get a better answer. It's xn minus f of xn, which will be this, and then what's the derivative? 2xn in this case. Right, so let's put x0 in. So x1 would be 10 minus 10 squared minus 4 over 2 times 10. Yeah? What's that? 196, 9.6. 9.6 divided by 2 is 4.8. Isn't it? We'll just use the calculator. 96 divided by 2 is, and divided by 10 is 4.8. 10 minus that, and you get 5.2. So that equals 5.2. Let's try using 5.2 now. So you put 5.2 in, you get 5.2 minus 5.2 squared minus 4 over twice 5.2. Let's see what we get this time. 5.2 minus 5.2 squared minus 4 over twice 5.2. Yes? So now we get 2.98. That's x3. 2.9846, etc. Getting closer. What was the answer? So I'll just get the calculator to do it again, except using this number. So if I hit equals, I get it again. 2.16. That's the next one.
Perfect.
And then?
It's reached it, so it stops moving. Yeah. So, etc. x equals 2. You like it? Yeah. There are some advantages and disadvantages. Advantage, it works for anything, nearly. Okay? Disadvantage, it only gives you one answer, but you know there should be 2 answers here. Okay? So, this method is nice, but it does have advantages and disadvantages. Advantages, it's easy. It works for most problems. Yeah, and it's pretty quick, especially when you can use your calculator.
Yeah.
But disadvantage, it only gives you one route,
So how will you find that out?
and so you can't find the other routes. It only goes to one. Okay, and it can get stuck.
Can I choose like minus 5.2?
Yeah, and it will get to the minus 2 answer. But that's because you knew there was another answer. That's why you changed it. You know what I mean? Yeah.
When you don't know,
Then you don't know. But it can get stuck. Okay, so this is what happens when it gets stuck. Watch. Here's our curve, and the root is here, and I start here. So we go up, draw a tangent, have this. Go up, draw a tangent, get here. And then what happens here when I draw a tangent? No answer. Because it's at a turning point. So it can get stuck, and also the derivative can't be 0 because you can't divide by 0.
Yeah.
And it can also get stuck as well. For example, let's say I start here. Hang on, let me draw a better one. Yeah, something like this. It has no root. I start here, go up, draw the tangent, get here.
Yeah.
Go up, draw the tangent, get here. Go up, draw the tangent. You know, it can get stuck. It will just keep jumping between these two values. You know? I can show you that too. Does this have any answers? Does this have any roots? No, because watch, when I draw it, it doesn't cross the axis. And then we want to differentiate. I get 2x. And my formula is x minus this one over this one. Like this. So let's pick a number to start with. Why don't we start with 2 and see what happens, okay? So let me put in 2. And I get this. 3/4. Okay, so let me put in 3/4. And I get this. Minus 7/24. So let me just write a formula to do this automatically. Okay, so let's start with, what did I say? 2, wasn't it? I get 0.75. Okay, let's go with 0.75. And I get this. And I can keep doing this. So let's do it many, many times. Starting at 2. And see what we get. I'm back at 2. What you can't see is what's happening here. It's just going to jump around. It can never get to the root because there isn't any root. Minus 1.38. It's just going to swing around left and right, never getting to the answer. Yeah. Okay. Have you ever seen anything like this before? No, this is completely new. Yeah. So if you look here in the questions, usually in the exam they tell you how many times to use the formula. Usually it's twice, because after 2 times you're pretty close to the answer. So here I give you the cubic, I give you where to start, and then I want you to use the formula twice to try and get to one of the roots. Do you understand? Yeah. And that's really it. I've put in some more questions, but it's not really too difficult. It's actually a very good question in the exam, because you just have to use this formula like 2 times on your calculator, and that's it. You know. So we'll just finish by doing this cubic together. Can you? Let's just do this cubic together. Can you write it down, please? It'll only take 1 minute. Quick. 54x cubed.
What is the difference between Newton and Hitler?
Between what?
Newton and Hitler.
There's a bit of a difference.
No, they both killed people.
Oh dear. Did you make that up?
No. And they died when they all people loved them.
I see.
They write it, but they, roll the stuff.
Write it down.
What's number?
54x cubed okay, you got it?
Yeah.
Okay, what's the formula? 54
X cubed plus
54x cubed plus
66x squared
yeah,
plus 35x
yeah.
plus 6.
Okay. What do we need to calculate? The derivative.
Yeah.
So there it is there. And our formula is x minus, what's on the top?
Oh.
F of x. Yeah, which line is that? Line 1 or
The line 1.
line 1 over,
Line 2.
and what do I put in for x at the start?
Actually at the start, we should put like 0.
0. And I get this answer.
Yeah.
And then that's done it once.
Yeah.
Now second time.
Yeah.
So now I put this answer in. Minus 2 over 13. And let me just approximate that. Oh no. Approximate. We'll say 4 decimal places. And we get this. Yeah.
So that means it was going to.
No. Would you like to know the true answers? Yeah? So, but I can get the program to give me the true answers.
No, that's not to write.
Did you write the first line?
Yeah.
Yeah, so I just need one line. So I'll get the program to solve this. And that's the true answer.
0.22 over.
It was 2 over 9, I think.
So close.
Isn't it? This is my answer, and this is the true answer.
All of the answers are right.
Pretty close, yeah?
Yeah.
Will we just put it in one more time to see what we get? So let's just put it in one more time.
Isn't the close answer that it can be or it is exact?
No, you can only get very close, but never exact. Let's put in one more time. We get this, which is really close, because the true answer was 0.2222, and we have 0.2221. Not bad. Okay. You're going to need to try some of these. They're good questions for the exam, and